The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
All right, welcome back, everyone. I can't wait to hear about your projects and trips. So today, you guys are going to do presentations. Then we're going to go through a really quick review of the design process, which is appropriate because we have a really quick design process to go through. And then you guys will do probably no brainstorming, maybe a little, but then doing pew charts to figure out what projects make sense for the class to work on this semester. And then part of that will be you're going to do like micro presentations at the end of the class that you'll prep during class so that you guys can select what projects you're going to work on tonight. Are there any questions or anything to note before we get started? Okay, and so ideally we'll do Grupo Phoenix first, and then Asa ProStar, and then Asa Phoenix. So do you guys want to start?
So hi everyone. For those of you who don't know us, hi Amy. We're Grupo Phoenix. We traveled to Sabana Grande, which is 20 minutes south of Ocotal, which is one of the bigger cities in Nicaragua for spring break. And we were there for 5-6 days, and we had a lot of fun. So the first thing I'll talk about, well, this is our group. I'll talk about our group. Jorge. I guess we should introduce ourselves. I'm Jessica.
I'm Vivian.
Liz.
Kurt. Juan.
Beautiful. And this is Jorge. He is like the shop manager, field, like on-site field kind of manager guy. He's a go-to guy. Basically, you hear his name over 300 times in an hour, being shouted, Jorge, get us this, Jorge, get us that. So a really handy guy. I hope were we able to give him a D-Lab hat? No. So next time. So we're not going to talk about this first. We're going to talk about the charcoal burn first. So when we got there, the itinerary was to do a lot of charcoal burns because that was one of our possible projects to work on. And there's a lot of opportunity there because when we got there on Monday, we had our first burn with them, and they showed us the briquettes that they had been able to make from their Friday burn, and this is what came out of it. And as you see it, remember from our briquette making, it's really gray, especially when you compare it to the blackness of this darker charcoal, which is a successful burn and a successful briquette made while we were there. So this is what we made with them. This is what they had made the Friday before we got there. And there was improvement. Yay. In this picture, you see all the white smoke, which is basically the water vapor from the barrel burning. And it's because when they used the Friday, this was using the same biomass that they used Friday, which is this corn stalk. And this corn stalk apparently wasn't dry enough. It seemed like it was dry enough, but only when we were burning it did we see that it wasn't actually dry enough for the briquettes. At the end of our week there, we were able to make over 150 briquettes from the 2 burns. And so we yielded 150 briquettes. Before, they were only making 6 to 7 of these briquettes for each charcoal burn. And they were, looking at us frantically because when we got there, they already expressed that they did have a big interest in charcoal making because they're starting. This is the solar center, and on the other side of the field is the restaurant that they're going to start operating. And one of the fuels that they want to use is charcoal briquettes to cook in the restaurant. So they wanted to make this like economically feasible and ready to sell for the people of Sabana Grande, possibly to resell it to Ocotal, and so we were able to get a better yield for them. Some quick lessons learned. So a little bit of the history. Amy came in after Judy. Judy is a random service volunteer that came to the women of Totogalpa, to the solar women of Totogalpa, and taught them how to do the charcoal burns. But apparently she taught them completely wrong because the timing on sealing the barrel, like we all know, was off. And so because of that, they were only yielding like 6 to 7, and it was like burning too much, so it was getting ashy. She didn't teach them little checks. So in essence, at the end of what we did is that Kurt and I sat down with 2 charcoal captains, we called them. 2 of the women were made charcoal captains because Kurt and I briefed them like extensively for like a 4-hour period and instructed them on like what the instructions meant, the diagrammed ones that we have in Spanish. And so we went over the translations because the Spanish that it was translated into sometimes was a little different in Nicaraguan. So we did that translation so that they could understand it better. And then we made them in charge of, as captains, they chose 2 other women, and that those 4 women were the charcoal committee. So these 2 women, the captains, instructed the other 2 women on the process. So now it's a little bit more of like an internal thing. You also learn better when you teach, right? And so by the time that we got there on Thursday, we regrouped. And on Thursday, we did the charcoal burn in the morning with all 4 of them just leading the way. They would say every step of the process before they did it, and it showed that they really picked up on it. And by the afternoon, they did another burn basically completely by themselves. The successful key points that they really picked, that really showed us that they knew what they were talking about, was when we would ask them in the middle of it all, just to check, how do you know if it's good, if it's a good burn? And they would say, oh, you gotta crack it open and the heart has to be black. And I would say, oh, okay. How do you know if the biomass is too wet? They would say, oh, because you'd have a lot of white smoke and that's bad. And I'm like, so what's the yellow smoke then? And then they'd say, oh, those are the contaminants. And I'm like, contaminants? But that's what the wood has when you're cooking with it, right? And they go, no, it's different because, and then they would be able to explain all the process and all the logic and really get to the why of things. Okay.
Cool. So we basically, for our second, for the Thursday burns that Jess described, we went out to the fields and collected biomass that had been sitting there for a month. So it was way drier. And so this prompted us to think about a possible project for us to work on, at least something to think about, which is whether to bring the biomass into the center and burn it there, or figure out some way of like being able to do the burns at the fields, like where all this dry biomass is. And because Sabana Grande is quite a large area, we thought maybe that could be something that we could think about, particularly from the cost perspective, which Liz is going to talk about in a little bit. But other things that we're looking at as far as possible projects are also this solar dryer for briquettes, because we discovered in interviewing the woman that the biggest problem they had with the process was having to air dry these briquettes for 3 to 4 days outside, and they didn't want to like take them outside each day and then have to bring them back in and then be worried always about the rain. So they work on these. Their primary work is on the solar ovens, but they also do solar dryers. So we experimented a little bit with using these, and we think that one project we could work on is a solar dryer specifically for charcoal briquettes, so they can start making these really quickly, kind of as kind of like almost like a factory, so that they can supply them to their restaurant and achieve scale there. And so this shows some more of the process. This is the new biomass that we brought in. That was a way drier. This was our second burn. And here, this was the briquette making process. So one other thing that we thought could be a potential project is experimenting with the like cornstarch versus yucca versus like using banana starch, because they can just buy cornstarch there pretty cheaply, and it's much easier for them to do that than have to like grind up this yucca for binder. So those are basically the range of projects that we're thinking about right now as far as charcoal. And if you want to talk a little bit about the cost study now.
So we also like really quickly did a kind of cost study so that we could kind of ensure that teaching them charcoal was actually useful, because they basically wanted to get paid like 10 Cordoba an hour, which is like 50 cents an hour, and work like 7-hour days. And so based on those numbers and like roughly how many burns we thought they could do in like one day, if they just kind of did like a bunch of burns in one day and just had a few going at a time maybe, we thought that like they would be able to sell it for like slightly cheaper than you could buy it in Ocotal, which was like a 20-minute bus ride away, so that it could actually be like a feasible option. And they also really wanted to use this charcoal in their restaurant, so hopefully if they really get into this and they kind of get a lot better at it, then they'll be able to actually use charcoal, and it'll be like economically viable as well as a clean alternative. I'm also going to talk about solar ovens, which I think, here we go. This is kind of like their solar oven that they have kind of all over the solar center. It's sort of like the symbol of the solar woman that we were working with, because it's sort of something that they build. They like paint them this bright color. They all like work a lot of hours in the solar center, and then like when they build up a certain like number of hundreds of hours, they can buy one for themselves. So some of the women have them at home, and they can use them to make things like cookies, which you see here, which they can't actually make like, you know, on a wood fire. So a lot of the women really enjoy them, and while they're not really a very economically viable option, they're sort of like a way of bringing the women together, which we thought was really interesting. There was a Cornell group there working on these solar ovens to try to improve their insulation and other smaller parts while we were there. So we worked a lot with them, and they actually built a new oven with fiberglass insulation while we were there. So we got to see how they were built. We feel as if there's not too much more that we can add to that project as opposed to the many other projects that are there. So really the only projects that we think we should possibly pursue with regards to the solar cookers was the solar dryer for the charcoal. And then that was the final charcoal that was supposed to be before.
So photovoltaics. So right now, they make these panels by hand. The way it works is that the group of Phoenix gets all of the extra small panels from the U.S. and they buy boxes of the panels that don't pass tests here in the U.S. And for about 500 of the small panels, it's about $500. The problem is that, so it's about $1 a cell. So about $1 a cell. The problem is that out of the 500 cells that they get, there's about 100 to 200 broken, depending on the box. So it's more than that. And so this is a really intensive process of making the cells. The panels, I'm just gonna go over it really quick. Okay, I'll explain this later, which is the setup, how you set everything up.
You want to just talk on this slide? Or was there another slide?
Yeah, it's the next one. Okay, so first they connect them all and they call them chains, like solar cell chains. They solder everything by hand and they test every single cell by hand and then every chain by hand. Then they move these chains independently to this paper. Nice. And then after they place each chain independently, they then add liquid silicon all over the panels by hand. And they have to make sure that it's evenly spread and there are no air bubbles. And then they get the glass and they have to put it evenly on top. Evenly on top, and then by hand they kind of try to squish out all the air bubbles that are still in there. Then they add foam and add batteries, and this is kind of like an annoying process because they have to put each battery at the same, all two batteries at the same time to have even pressure across the cells. And they leave it there for 24 hours so that the last air bubbles can escape and so that it can be completely flat and even. So there's obviously a lot of improvement. It takes about 24 hours to make one of the large solar panels, and they produce about 220 watts. So some of the projects we were thinking about were, he mentioned instead of having to place the batteries to have you in pressure, maybe just an even way that you can just pull down and it holds down the pressure. We're also thinking about having some type of vacuum pump or vacuum chamber that just removes all the air bubbles, so you don't have to do it by hand. There's also there's also another thing. So they're thinking about using ethyl vinyl acetate instead of the liquid silicon to cover and insulate the solar cells. The problem with the EVA is that it has to be heated, and then there's also air bubbles even if it does heat up. So another possible project is a way to heat it, maybe using the solar ovens, which they say they did. Or maybe maybe another way. That could be another possible project. Okay. So those are the large solar panels, which they use for the homes, and they using to power the restaurant, and they're also using to power the solar center. Then they're trying to make the small solar cell phone chargers, which you saw last time, and they're trying to basically model to this. This is worth $10 in Ocotal. And it's made in China. The great thing about it is that it actually comes with a cell phone battery. It fits most Nokia cell phones. And what you see on the right side is a charger as well as a lamp. So not only can you charge your cell phone, you can also use a battery to power up a light. So that'll be like the ideal project. So yeah, that'll be an ideal project. Currently, what they're working on is just the solar cells, and because they need a smaller voltage and they don't really have much access to capacitors or resistors, they cut. Go back to it. Yeah, they cut every cell by hand using a Dremel. So that's another cost, and another way to cut the cells instead of having to do it by hand would be another project. And what I have here is a little all-battery cell phone charger. So you basically put your battery here, and then you move around depending on where your battery is, and you can charge your cell phone. You can pass it around if you want to see it. And so we were thinking of installing that to the solar panel, so you could charge any type of battery, not just Nokia, ideally. What else?
The main issue with that is also the cost, because like we were having a lot of trouble figuring out how you would actually, like, using their current system, their prices would be a lot higher than the China-made one, which is hard.
Yeah, so right now the costs are really the biggest issue. The fact that each solar cell is about $1, then the silicon, they use about 600 grams of the liquid silicon right now, and that's, I forget the number off the top of my head, but I think it's about $100 for 5 gallons, and just everything adds up. The labor, I think, is the most intensive part. They really use about 12 actual hours, 24 hours with the drying included. The glass is relatively expensive, and then there's the aluminum on the side. There's also the tape that they have to do it by hand, which is not really tape, is the little aluminum strips. So that could even be another project. Instead of have a aluminum tape that you can use tape instead of having to solder on. That could be another great project. And so we're gonna keep talking. Oh, and Mauro. There are two people that really make the solar cells right now, which is the guy on top left, which is Mauro, and then there's another Mauro, which is like little Mauro and big Mauro, who's the only male member of the cooperative of the Solar Woman of Totogalpa. Yep, that's what it.
Cool. So once we spent like a couple of days there, we kind of realized that a lot of the center is focused specifically towards like 20 women who are part of the cooperative. And so we began wondering if we did design a project like based on what we learned at the center, would it only benefit those 20 people, or would it help, the surrounding area in general? And so, so this is actually the only slide that we have for that part. But basically, what we decided to do was me and Kwan walked a couple of kilometers down into another district called Santo Domingo, and it's the road we walked on. And so Santo Domingo does not have grid electricity, so they're basically cut off from like any conventional electrical appliances. And so we wanted to go there and ask them what their involvement with the center was, if they had considered other options for, like solar or wind or whatever. And so we asked them a bunch of questions. So the first thing we asked them was if they had heard of charcoal, and we interviewed 10 families, and none of them had used charcoal. 3 of the families hadn't even heard of carbon, which is so they didn't know what it was. We then went on to ask them what they did use to cook, and they all said firewood. We asked them where they get the firewood from. All of them get the firewood from like their surrounding communities, but there was actually one woman who like walked 3 kilometers every day just to get firewood, which we thought was kind of like, unfortunate. We also asked them after that if they do use some form of like lighting at night, and if so, what. All the families we interviewed did have some kind of lamps at night. Mostly they were diesel lamps. We weren't sure exactly how that worked, but they all either used diesel or akote, which is pine wood, or electric lamps, which run on batteries. So once they said that they do use batteries, we asked them what they did use batteries for, and it turned out that they basically use batteries for like 3 things: lighting, radios, and if they're big 9-volt batteries, then you could power like a cell phone charger. So once we asked them about that, we also asked them about like how many cell phones they have, or if they did have any per family. And 4 out of 9 of the families we interviewed had cell phones, but the rest didn't. And for the families that did have cell phones, we asked them how they charged them because they weren't, near the grid. So apparently, what they do is they walk to a house which is in Sabana Grande to charge their cell phones, and are charged 5 to 10 Cordoba for each, each cycle of free charging. Apart from that, we also asked them if they had cycles. This was just out of curiosity, because like we were wondering if pedal power was if it was viable, and every family did have at least one cycle. Apart from that, so a cell phone battery charges for 5 to 10 Cordoba, and a 12-volt battery charges for 30 Cordoba. So this was, that was pretty much it. We just wanted to get some perspective on off-grid communities, and that's pretty much, that's what.
Okay.
You guys were supposed to do a 10-minute presentation, so we can just go.
Okay, real quick. Okay, so while Juan and Sid were doing off-grid interviews, Liz and I did some interviews at the different homes of the women, and we also had a day where we cooked with the women, just to gauge their usage of charcoal, whether they're using it or not, and reasons why, and just to really get an insider's perspective. So we found out that most people aren't using charcoal. They prefer to cook with wood over charcoal, basically because they can gather it for free. They don't have to pay to buy the charcoal. They don't have to go to Ocotal to buy it. And they say tortillas are a very big part of their diet. They get up early every morning, go to the molina to grind the corn, go through this process, and they make tortillas every single day. So it's a very huge part of their diet. And they found that the charcoal doesn't burn hot enough to make the tortillas, so they prefer using wood. And also on their adobe stoves, you can cook multiple things at once, which is also why they prefer wood. So this was a good idea, or a good inside look at why they're not using charcoal. We also saw when we were cooking with one of the women that she kept on using tinders from the wood fire, and she's dumping it into the charcoal to try to light it. She was having a really hard time doing that, and a very small side project is just better charcoal education, and I think it's going to be really important to make this charcoal affordable so that they will see this as an option over wood. Another thing we surveyed the families about was their electricity usage, and we noticed that most people, if they had solar panels, they were bought using green hours, and because these families don't want to pay the extra amount for an inverter, so all their solar panels are used for lighting in their homes. Some families are lucky enough to have enough money to pay for grid electricity, which they use to charge cell phones and for some families have TVs and radios. Other families that are only dependent on solar panel energy, who also have cell phones, we saw go to their friends' houses to charge phones, and which gave us the idea of having maybe a community charger, community solar power, or some sort of center where we can invest in various panels that does have an inverter to don't charge these cell phones instead of them borrowing their friends' grid electricity and stuff like that. I don't know if there's anything else. Oh, and these are some of the homes we stayed in, and we had a good time staying with them and learned a lot just from living their everyday routines and stuff like that. I think that's about it. If anyone else has anything to add.
Any questions? Ideas, comments?
We have a lot of projects.
Yeah, so today you guys are going to have to work hard to narrow them down. That's okay.
Sorry for going over time.
Thanks, guys.
Thanks.
So hi everyone, we were working with ASA ProSAR in Santa Ana, El Salvador. And while we were there, we worked on 2 main projects just to show them and work with them to demonstrate. We did 3 charcoal burns, and we showed 3 different communities how to make corn shellers for themselves, so bringing down a project that had already been done. We're just going to run through kind of some of our pictures from charcoal and explain kind of how that went. So at first, they didn't have an oil barrel when we went down there, so we had to go to the cooperative in one of the communities and find an oil barrel first of all, and then find someone to cut the holes for us. So Miguel was kind enough to drill our holes, and then we brought it to the community, and we did 3 different communities on 3 different days, and all 3 communities that we went to were really eager to help. They all wanted to be a part of it. This particular guy right here, it was part of a community that was looking at charcoal more of as an economic goal, I guess. They wanted to sell the charcoal as opposed to using it, because they had just acquired new stoves where they were using wood that were outside, so they're better for ventilation. So these are just some of the pictures from that. They were all really excited about the charcoal. But the first day, our burn didn't go so well. We learned that using pretty wet sugarcane wasn't great. They hadn't dried it very well, and sugarcane to start with was a lot more dense than some of the material we had used when we burned here, and we just didn't let it burn long enough. But it was also good for the community to see that if they didn't let it burn long enough, then they wouldn't get good charcoal from it. Did you want to add anything?
And another thing we realized is that the first day when we graded the yucca, we did it in relatively bigger pieces, so it was still pretty dry. It didn't release any of the juice or whatever it has in it. So when we ground it up, it was still really dry, and so when we added it to the water to make the binder, we had to use so much yucca to get it to have that right consistency. So what we didn't make the one yucca didn't make a whole lot of binder, so we learned to put it in smaller pieces to make.
You can see kind of how thick it was. This was the first
really thick.
I think it's important to note that in all communities, some people were somewhat familiar with charcoal. Sometimes they had no idea, but it was really nice that everybody. I guess we kind of expected that, but everybody worked with us, and they came up with their own little ideas, and the 2 tour guides, not tour guides, that's a bad word, the 2 people helping us from the organization, from ASA ProSAR, were very helpful, and they got really into it. And so for the last one, we actually asked them to do the demonstration, and we were kind of checking and making sure everything is okay. So that worked out really well in terms of involving the community actually to keep doing this, because they're going to keep showing people in different communities, so it was important for us to involve them a lot in the process.
Yeah, they got it down really fast. Yeah. So by the 3rd day when we let them run it, it was all in Spanish and we couldn't follow most of it, so we would ask our translator, Juan Carlos, who was working with us, and one of the 2 people who was working in the community, we asked him, did you remember to tell him this? I was like, yeah, I got it. So he was a total pro. So it was really good. It's really exciting to know that they'll have the know-how and the confidence to really accurately tell more communities how to make the charcoal.
And this is Elena. She was one of the other community partners that we worked with. She was really into the motivational aspect of it, so she'd always be like, "Si se puede," you can do it. She kept encouraging the people in the community who are a little more nervous about it, or who are more depressed about their living conditions, that they could keep moving forward. So she was really excited about the charcoal. So move on to the corn charcoal.
So it was a lot of fun that pretty much everyone in the community was really involved with it. We, at least on the last day, we really kind of sat back and didn't really do anything, and let Juan Carlos and Elena take the reins, at least with the instruction, but still the entire time the members of the community were really doing everything, and they jumped right in. No one was really very hesitant, and there was something a little bit for everyone to do when we crushed up the charcoal. There were a lot of kids in the area, so they just went to town stomping on the rice bags. It was really a lot of fun, and the person that drove us to the community, what was that? Julio. He one day he sat there and just made charcoal brick after charcoal brick, and he was like, "Oh, look what the ones I've made." So everyone was really excited about it. So that was nice.
So with the corn shellers, Amy Smith had gone down, and some of the communities had seen or had heard about using cans that they had to make the corn shellers. So we had never heard of that, but we were kind of trying to go with it. And the first day that we went out, we had to experiment with using pliers and the cans that they had. So this was one of the communities that they were just playing around with it, and it was almost kind of good in a way that we didn't really know how to do it ourselves perfectly, because it kind of allowed them to experiment themselves with it. They kind of found the best ways that they wanted to make it. They're using little 6-ounce jalapeno cans. So these are some of the women playing around with it. And then we also did show them how to use the jig with the sheet metal and the hammer. One of the things that we ran into, though, was one of the communities didn't have pliers, so we had to show them how to do the whole thing with a hammer. And eventually, by the third day, Amit came up with this idea of having a variable corn sheller, so we didn't actually close it, and we rounded the edges. So it's just you could hold it in your hand and adjust it to the size of the corn, because the corn varied a lot from different communities. So that was really helpful, and this girl was really into it.
Yeah, it was nice when we found the way to do it without fully attaching the ends, so that since a lot of the corn were different sizes, you would see a lot of the members of the community use one corn shell and try to shell it, and it didn't work because it wasn't the right size. So they'd toss it out and try another one, and you could see it was kind of frustrating. Who wants a corn sheller that doesn't actually work? So once we figured out how to do it with just rounding the edges, so you could how tightly you gripped it, what made it work for every single corn cob. It was a lot more exciting. And when we first showed it to them that day, the lady tried and promptly put it in her pocket and went around with it with the rest of the day. It was amusing.
The third community we went to, actually, we went and toured houses and looked at stoves in between when we had first shown them how to make them, and we came back a few hours later, and they were still all sitting there making them. They had been doing it for hours on end. They loved it. It was really cool. Now we're going to talk to you about some potential projects we came up with.
So there, I guess as an introduction, because our trip was we just went with it. We really didn't know the exact projects they were working on, so we took a lot of notes. And there's so many different issues that they're dealing with, and a lot of them are not energy related per se, but we took notes on all of them, and we'll I guess we can pass that on to other D-Lab classes. But we picked 4 as the main projects that we can focus on in the class, and I guess the main ideas were lighting optimization, ventilation, a charcoal insert, and a rice husking, modifying a mill to do rice husking. And how do you want to do this? Go ahead. Yeah.
So one of the big problems in El Salvador is there's only 3% forest right now. They're running into a lot of issues with people using all the wood for cooking. So although some of the families wanted to use the charcoal to sell it and make money off of it, other families were looking at it as a fuel source for themselves for cooking. But one of the problems with that is that the ASO ProStar team was working with the communities to build new stoves outside, and those stoves weren't optimal for charcoal. This is a picture of one of them. See, if you can see, it has the nice chimney, so it ventilates really well, and it's outside. And it burns really well with wood. So we were thinking along the lines of something that we could insert into one of these types of stoves that would make it be able to use charcoal. A lot of the materials that they have there, we thought about sheet metal, and we thought about different ways to kind of make a kind of fryer basket thing, but sheet metal is too expensive for their living means. So for our project, we were thinking about something with the cans that we had talked about they use for corn shellers. they can buy them in the market, and they have food in them when they come with them, so that they can use the food. And then we were thinking about potentially making the cans and just like forming it and weaving it into some kind of charcoal basket that we could insert into these stoves, so they could cook with the charcoal that they make.
It's something important, I guess, to add for all of these was that I think all three communities, and I think one was a little bit better than the other ones, but they really didn't have any resources. Like, we spoke to a lot of the people, and it seemed like most are women, most of them are not working. So it was really difficult to ask questions like, well, can you afford buying something? Because most of the time they don't really have any money. So I guess the biggest challenge is try to find materials that already exist or maybe are part of the trash. And we spoke to people trying to figure out what are the type of things that they can find. And I guess the cans is one of the things. Also, the empty chips bags was mentioned as something that it could be found near schools. Plastic bottles, any size of plastic bottles can be used. So things like that, we were trying to see if we can somehow incorporate any of this into the design, so that it's not really something that you can go buy, because they can't really go buy it. So.
You want to talk about that? Yes.
Okay. So the second problem that we identified as something we could address was rice dehusking. So some of the communities were starting to experiment with integrating rice into their diet, as well as their standard corn and beans for additional nutrients, or at least having it as another source of to sell potentially. But currently the problem was if they could either shell all of the rice by hand, or they could take it to a mill that was about 3 hours away, and they had to pay about $2.50 to get the bag dehusked, and then they had to come back. So it was a very long and tedious process. They spent well over their a couple days salary or work just doing this, and it's really not very economical, and it's very hard. So they experimented with a mill to grind, that they used to grind corn to dehusk the rice, and they to make it softer, some of the communities had put rubber in between the pieces of the mill, but they found that the rubber was turning the rice kernels black, and which is not good. So we bought a couple mills and experimented with other materials, which included a lighter color rubber material and leather, so it was more organic material to place in between it. And we tried that Saturday before we left, and we had a decent amount of success with it. There has to be some more fine-tuning, obviously, and probably more to potentially find some more optimal materials to use as the barrier. But from what we found, it's definitely got potential and shouldn't be too hard of a project to tackle. So.
And that's something I think that's also supported by ASA ProSAR. They're supplying these mills to some communities so that they can use it almost as a microeconomy to make money out of it.
The insert kind of goes right in between these two pieces, because they're both I guess ridged, so they grind against each other, but when you have something in between, it kind of stops it from pulling the rice totally apart.
For the lighting, there were a couple of different issues. One was electrical lighting, and one was day lighting. For electrical lighting, some communities, some people had lights inside, some had lights that worked and some that didn't work, so it varied, the conditions varied. However, the families we asked about, is the light bulb enough? A couple of families said, yeah, for at night, they had one room in a way, and that it was sufficient to light that room. In terms of daylighting, so the houses were completely
very dark.
Very dark. And one of the, I guess, some of the questions we asked are why are they so dark, and is that more of it's expensive, or do you need more light? And so most of them were 1 or 2 rooms, and they had 1 window, the whole house. So one of the rooms sometimes didn't even have a window. And we found out that there were a couple of different issues. One was money, because the houses were made with adobe bricks. In order to leave, I mean, it seems simple that you just leave an opening so that you actually save on material. However, for safety and also for hurricanes, they have to close that opening. And to close that opening, if they use wood or metal, it costs anywhere around $25 per window, whereas the bricks are 30 cents. So that's $3 versus $25 is a big difference. Another issue they said was some of them didn't actually want more light because of privacy reasons. Parents and kids sometimes are in the same room, so they were kind of joking around, but they said, we can't do anything because if you can see things, kids are always aware of what the parents are doing and the other way around. So it was more of a privacy issue. However, daylighting could be improved, or it would be great if they have more light for all of the tasks they're working on. And some of the ideas we had were, again, using existing materials. And so we saw this at we met a Peace Corps person from Texas who used this in his house, and he said that the roof was leaking, so he just put a plastic bottle instead of one of the roof tiles. And that was actually, we thought, a really great idea, because plastic bottles are available. And if we can find a way to maybe cut the bottle in half and try to mimic the shape of the roof tiles and incorporate some plastic bottles within the roof so that stops the rain but allows light to come in. That was one idea. Another possibility was there was a gap between the wall and the roof of about 6 inches in most homes. And even though that's a lot more challenging, we were trying to think of, is there anything that we can introduce, some sort of a surface that can catch some of the light from the outside and bring it inside, something like the chips bags, which is kind of like aluminum foil, to redirect it. However, that's challenging because the roofs or the ceilings and walls were completely black from the smoke of the cooking inside, which I guess leads to the last.
Yeah, so I guess the last project we were really working on was the ventilation. So like Yulia said, like a lot of the homes still had the stoves inside, and a lot of them were simply the 3 brick stoves. They just stuck the wood under it and proceeded to cook, and it essentially charred the walls completely black. And it was covered in soot, and with the financial problem of trying to even incorporate windows into the housing, which is so much more expensive, that we really had a difficult time trying to think of ways to improve the ventilation, especially considering the fact that a lot of the members of the community on it don't make money. They just live off the land that they have. So the idea of buying materials is pretty much impossible. So one of the thoughts we had, other than improving the stoves so that they're more efficient, trying to get them to move outside, which they have problems with, since the stoves they have right now are not very efficient. They have to make sure they close off the entire area for wind and rain because they're already losing efficiency just with the stoves they're using. So a lot of them wouldn't mind, like, if they don't leave the stove inside, they build like an entire new room with a roof and a wall outside of the house to put their...
So this was the start of one of the like outside kitchens that they're making. So they like literally close a section off with walls, and then they're gonna probably put something over for a roof.
So essentially they're making an entire new room.
And that's supported by Asa Prosa. What they're doing is trying to find families who are they have the most need in a way, and they're supplying them with sometimes materials. They said that the way the organization works is they never actually do it for you. They would get a grant from somewhere and actually make the community do it. But these stoves that they're building outside or kitchens are not for everybody in a way. So there are only certain families who get them. So it's still a really big issue of how do we deal with the stoves inside.
Yeah, so we thought as far as a makeshift smoke hood, essentially, since there was the gap in between the house and the roof, we thought that maybe we could make some sort of hood out of the materials that they already have, maybe like overused clothes or even like the chip bags, if there was some way to like sew them together and channel the smoke at least up into the cracks of the house and hopefully guide it a little bit more outside of the room that they have, because essentially they are just one room huts more or less, so they're with no windows and one doorway, so there really isn't anywhere for the smoke to go if it can't be better channeled out. And since it is only one room, you sleep there, you eat there, you cook there, so the ventilation is pretty bad, and it's one of the things we really want to work on. But ending on a more positive note, though, it was an amazing experience. Like we said, all the communities were very encouraging and really wanted to make these changes. There wasn't anyone who was just kind of the woe is me, too depressed to even try to make the change. So it was nice to know that they were really, really into making these improvements. So.
I guess just to add something important was ASA ProSAR, the way they work with these communities is to help them, but to also help the land. So there was a really big influence on how can we make some of these improvements but not hurt the remaining nature that we have. So a lot of the other issues that we encountered were water, latrines, how do they make them without actually contaminating the water. So I guess part of these challenges is to figure out ways that don't hurt nature any more so than what is already existing, because that's one of the biggest issues they're dealing with there. Yeah. Okay, guys.
Okay, so introduction-wise, we were the group that went with Also Phoenix. Also Phoenix is a group that's based out of Managua. It works with a group called Green Empowerment that's based out of Portland, so it's really quite a good collaboration. But anyway, they focus on bringing kind of potable water systems, green energy solutions to different towns. But the really cool thing is when they go to implement these things, they bring a lot of infrastructure with them because, we're going to install a water system. Well, you're going to need an energy source for your pump. Well, you're going to need a road to get all your equipment there. Well, everyone should have a clean latrine so it doesn't dirty the water system. So they really do a lot of compound work, and that's why it was really exciting to travel around with some of their interns, see what they do firsthand.
So I guess we'll just run down. We went down there with 4 projects in mind, and we are going to present those 4 projects and where we see further action, like possibilities for each of those projects are. So we'll start with the juice sealer, the bag sealer, which was a project from last year's class, which seals a plastic bag for so that they can preserve juice that the women are working on in the community. So we went down, and this device runs off of power from a 12-volt battery, and we went down, and since last year they have installed and connected a micro hydro plant to about half the houses in the community. So this house that we were staying in actually had 120 volts of power coming out of a normal outlet in the wall, but they did not have any more batteries that were not dead. So we tried multiple ways to get that to work.
Clarification is coming out of the wall was AC, and the device had a solenoid that did not like AC at all. Therefore,
the solenoid really didn't want 120 volts.
Yeah, there's that too.
So we tried reflecting with a corrugated metal piece of roofing onto a solar panel, but didn't have enough like current coming out of that to run the device. And then we also tried charging a battery, a car battery that they had from before the microhydro plant, but that battery was completely dead, and like it charged from like 1.5 volts to like 1.9 volts in 3 hours. So then we strung up those batteries that you saw in the last picture here to get it to work so we could at least give a demonstration, and that was some good compo engineering. So we were able to give a presentation, and they were pretty excited about like being able to seal the bags, but leaving them a string of batteries on a stick taped together is not something that's sustainable. We for this project we can further develop it by making it so that it can run off of the AC power that they have. And then we also found out after they left that some houses that aren't on the hydroelectric grid still have solar panels and charged 12-volt batteries. Bettering the design for this project to suit that, because they might, depending on what we hear back from Also Phoenix, they might have to take out the air in the bag, so that the seal would have to be a seal for the juice, airtight and no air in the bag, to completely preserve the juice so that they can sell it after the peak orange harvesting season when there's a market for orange juice. Moving on to, sorry, these aren't in order. Biogas.
Sure. So another cool project that we got to go and see was a biodigester. This is the same one that we went and saw in a town called Puerto Ritos. It's hooked up to the grid, right? Yes. Yeah, power has come to Puerto Ritos, but people still cook on wood stoves, and a great way to supplement that is with methane from biodigesters like this one. So this one belonged to a household where the woman cooked twice a day on it, but it would often run out. She had really no idea how much gas it was producing. So one of the projects we went down there with was to make some sort of simple yet elegant meter for her to tell just how much gas was in it, a pressure meter essentially. Do we have a picture? Yes. Okay, so our simple compo engineering solution was to take a piece of clear tubing we had brought, mark off some increments so you could see whether or not the gas coming in from the tank, which is the gray piece of conduit there, would press against the water. So basically you would read where the water in the tube met the air, and it would indicate if the pressure had risen or fallen. It's also a pressure release system, which is really important if the bag gets too you don't want the bag to get too overfilled with gas and the pressure to get too high. So basically, if the pressure somehow got to the end of that 6.5 inches of tube, which is highly unlikely since she uses it every day, the gas would simply just bubble up to the top. However, there were some difficulties that we noticed, like with the daily feeding this machine, or this system, just in the basic use of it. We hopefully solved that one with this kind of simple meter, but another one was it's a very messy task. Basically, it's a whole 5-gallon bucket of manure that has to be mixed at a 1-part manure, 3-part water mixture, and then added and poured through, if we go back to the picture of the entire system,
I think it might have
poured through a relatively narrow pipe, and it's just very sloppy and messy. It also entails mixing the, manure and water in a bucket. She had like a little trowel that she did it with. Bus and I got nice and dirty giving it a try as well. It's just a messy procedure. If we could come up with some sort of device that would mix the slurry in the bucket as well as kind of aid in pouring it, not only would it make this a lot easier to use and, be able to make her or help her get her chores done much faster, but it would kind of make biodigesters less messy in general, and I think we imagine that would be an applicable market for biodigesters in the States, biodigesters in other developing countries. It would be a very transmutable project.
Okay, so one of the things we went down
we did a lot of thinking about before we went down was doing a washing machine. So we had some extra time in Puerto Rico since we were waiting for the biodigester to see if our levels of gas was changing. So we talked to several of the women and got them to show us how they're washing clothes. In this case, they're doing it in lavandera, a big concrete wash basin thing up by her house, but most of the women were actually washing them down by the river. Pictures? Yeah. On stones, and you can't see it, but there was a well off outside of that picture. We asked them a lot about. So washing the clothes by hands involved a lot of vigorous scrubbing and also used a lot of water. In this case, we were using about that entire 2-gallon bucket to wash one shirt. She said that she used, I believe it was like about 30 gallons of water a day for doing the washing. She did it every day, and this was only she was only doing the washing for three people, because most of her kids were grown up and not around anymore. So imagine that a lot of families that are larger would use even more water. So we started asking about what they think about the task of washing and whether they would like to use a machine or not. And it turns out that there's actually very mixed feelings about the task of washing their clothes. Some women really don't like it. Some enjoy it more than other tasks, and so would rather do that. Some get bored and say that it's something to do, and so they enjoy it for that reason. And if we asked them if they would use a bicycle-powered machine, in general they were we think they didn't really understand the concept of powering a machine off a bicycle. It was a very hilly area. We didn't see a lot of bicycles, especially off the main roads that were paved. And it might have been better if we had had pictures of that to show them the idea across. But in general, the response was that they didn't know if it worked, and if they liked it, they would use it, but they couldn't say now. Some specific things about Puerto Rico is that they have a potable water system, and they pay money for it. So if there was a machine up by the house, they'll do their washing still by the river. So if there was a machine up by the houses that they would have to use, it would have to use almost no water because they don't want to pay for the water. The well that was by the river, which we thought might be a good place to put a machine, was actually built by a few families, and they own it, and other people aren't supposed to use it, and they own the land that it's there, so that would cause issues about who could use the machine, who it was for. We considered a portable thing that would be brought down to the river, but there's already a lot to carry down, and it would have to be very lightweight and not bulky. And then in general, there isn't things that the women aren't doing because they're washing clothes. It's not really taking time that they would be spending, like making money or anything, and especially with the finances in most households controlled by the men, there isn't much motivation for them to spend money on a machine to make the task of washing clothes easier. So in Puerto Rico, we found that there were a lot of obstacles, and we didn't think that it could really be implemented successfully there. We moved on to El Jocote, which was where we originally imagined the project, and there was a better situation. They had one place by the river that everyone washed for the dry season, and there were already a couple lavanderas there that the women would use, and there's often multiple women there. But again, it's only the dry season that's everyone there. Everyone spreads out along the river during the wet season. They're getting water pumped to their houses soon, so people are unsure about whether they're going to be washing up by their houses, especially if they have to pay money for it, or down by the river. There's a main path that goes right by the place where they wash their clothes, and lots of animals come by there to drink and stuff, so it would need to be very secure against the theft and the animals. We also heard that sometimes the women will fight over the best spots to wash their clothes, which we would be afraid that a machine that made it easier might exacerbate that, unless it worked so quickly that no one minded the waiting time. And then we had the same concerns about like the possibility, motivation for fronting money for a machine. Water conservation was talked about in both these cases, but we were there in the dry season and it didn't really seem like they were concerned about actually running out of water. So we're not sure that that would be a good motivation either. So even though we did a lot of thinking about this beforehand and the situation would be slightly better in El Cote, we don't think that it's really an appropriate project to work on, especially compared to other projects we saw. It seems to be more of like a solution in search of a problem than something that needed to be solved. And if somebody really wanted to work on a washing machine, I think the best way to do it would be it could be maybe be done as like a demonstration thing that Also Phoenix would have to give people a better idea of what we're talking about when we say washing machines and bicycle powered and stuff. But it would need to work really well in order to convince them that it was something worth switching to. So overall, we feel that a lot of the other projects are far more worthwhile, and this probably isn't something to be pursued.
So our last project was a millet thresher, which this is millet here on the head, and this is the raw grain after the processing. So in the town of El Cote, most of the families grow millet, and the processing of this plant takes a long time. It takes like a total. So to harvest like the fields, it takes between 4 to 6 days of like one man working. So normally I have 2 men do it. It takes between like 2 and 3 days to do that. Then they wait 8 to 15 days for the heads to dry, or for the stalks to dry, and then they cut the heads off of the stalks, which takes another 2 to 4 man days. And then the long time consuming part is knocking the little pieces of grain off of the head of the stalk. And the way they do this is they have this device or platform here where they stand on that plank, and then take the stick and hit the heads, and then the grain falls out, because that's just pieces, like individual sticks going across the bottom of the platform, so the grains just fall through onto the tarp. Normally they'd have a bigger tarp at the bottom of this, but they just saved one bag and their harvest had ended before we got there. So, but Jaime, the director of Also Phoenix, requested that they save a bag to show us. So this is just one bag that would normally have a bigger tarp. And then there's a guy below who's sweeping, and that's because parts of the head stalk, not the grain, but the head stalk also fall down, and he's sweeping those black bits out of the pile of pure grain. And then, so normally in their process, they'd have 2 men on the plank, 1 man sweeping, and then another man loading more raw material up on top. So it's a 4-man process, and it takes anywhere like between like 4 and 10 days for each family to process their harvest, depending on their size of the field, depending on the yield for that year. So it's a lot of time, because that's 4 men working for 4 to 10 days. So that's like upwards of 40 man days to complete this task. So the men don't like doing this work. So there's like a very easy, if the machine works, they will use it. And it's as simple as that. Then when you hit the heads, of dust is like emitted, and that stings your skin, makes it really itchy. And it's also not very good to breathe. And the man sweeping below is just engulfed in this dust like during the entire process. And they said they don't necessarily switch jobs that often, so it could be 1 man just sweeping. So what they do with this millet, they cook with it. They feed the leftover heads and the mixed grain that the guy's sweeping out that has bits of black heads to livestock, where they can also separate it, because the grain in water, the grains sink and the parts of the stalk stay floating. So let's see. For like this project, if it would be great to have a machine that gets like 80% of the seeds, because this hitting process doesn't get 100, doesn't even get close to 100% of the seeds out of the head. So if you were to get 80% of the seeds, that would be like acceptable for a machine, especially given that their efficiency right now. And then also, if you had a way to control the dust from expanding off of the machine, or if you could keep it sequestered, that would also be increase the health of the machine. And so that's it.
Thanks, you guys.
Any questions? Yeah.
So it's literally just sticks all the way around. It's like you can see the walls better from here, but the bottom is the same. And the reason that it's so high is so that you can have a man down there sweeping, and he's not like hunched over. So, and I don't know.
As it falls down to the dust that's with it, they don't really want that to get in the rest of the grade. So when it's falling down, the wind will blow it away. So that gives more time for that to happen too, probably.
I have a question about the biodigester. I know you went to that one last time, she had one, but are there other people in that community that have something like that set up, or was she kind of like a special case?
There were two in the community of Poteritos that we went to. We only saw the one, and they have about 10 Osophoenix that they've I guess installed already, and they're going to kind of continue installing more. Only 2 of those 10 are operating right now, like successfully running, and that was including the one that we were working with in the 10, which we're not really sure how much she's feeding it and how much she's actually using it. So I don't know, it's hard to say. Like a big thing, we're not sure whether it's because of the mixing process that it just is unappealing to, like, what is the logjam that's like creating like this gap between like getting the gas, using it, or not. So if it's that mixing and we can like take the human element, like human handling out of that process, and it would use it every day, then that would make a big difference. But if there's another problem, like we'd have to address it more.